Imagine tracking two runners to find the ratio of their positions near the finish line. If they finish at the exact same moment, their positions both approach zero, giving us the confusing fraction, 0/0. How do we make sense of this? This is where L'Hopital's rule comes in. Instead of their positions, we look at their speeds. The ratio of their positions near the end is ultimately determined by the ratio of how fast they are moving, their derivatives. Mathematically, if a limit results in 0/0 or infinity/infinity, we can take the derivative of the numerator and denominator separately and try again. For example, take the limit as x approaches 0 of the sine of x over x. Direct substitution gives 0/0. But taking derivatives, the sine of x becomes the cosine of x, and x becomes 1. As x approaches 0, the cosine of 0 is 1, so the limit is 1. This also works for the limit as x approaches 1 of x cubed minus 1 over x squared minus 1. Taking derivatives gives 3x squared over 2x, which simplifies to 3/2. Sometimes we must apply the rule twice. Take the limit of e to the x over x squared as x approaches infinity. The first derivatives give e to the x over 2x. Applying it again yields e to the x over 2, which clearly goes to infinity.